Clip farming?
Yeah. Clip farming is basically like you do something like while you're on live stream on purpose, like in an attempt to like have people.
You're
For
just
views.
embarrassing
Yeah,
yourself.
yeah.
Oh.
Yeah, it's just for views basically. Just do
Gotcha.
stupid stuff on purpose and try to play it off.
Like, do it for the vine.
Yeah, I got you. I don't think he knows that means.
Yeah.
That's okay. We're going with it. So the answer is yes. So identity element for a square matrix 2x2. Okay. So identity for 2 is going to look something very similar to what you've seen. It's going to be 1, 0, 0, 1. That's the identity element for matrices, for matrix multiplication. Obviously, matrix addition, it would just be 0, 0, 0, 0. But for matrix multiplication, it's going to be 1, 0, 0, 1. What do you suppose it's going to be for a 3x3 for matrix multiplication?
1, 0. Wait. Yeah. 0, 0, 1, 0, 0, 1. 0, 1.
You got the ones diagonal, everything else is zeros. Okay, so those are going to be the what do you call it? The identity element. Okay. So let's try one here real quick and see if we can't learn a property about matrices, identities. Okay. So let's let A equal. I keep going to my notes. I could just make up anything I want here, but let's go with 4, -2, -7, 5. Okay. And then let's take A times the identity matrix for 2. Okay. So what's that going to be? That's going to be
1, 0,
4, -2, -7, 5 times, now you can say it.
1, 0, 0, 1.
Exactly right. And let's see what that equals. Okay. So you remember matrix multiplication, right? We do row times column. First of all, we have a 2x2 times the 2x2. So yes, they can be multiplied, and my final answer will be a 2x2. So make this one a little bigger so I can put in some things here. 1, 1, 1. And you remember the multiplication, right? We start here with 4 times 1
4.
plus, and then you go over and down, right?
Yup.
-2 times 0 is,
0.
so I'm left with 4. What do I do for this one here?
0 times 4.
Okay, row 1 times column 2, so 0 times 4 is 0, plus, I move down and over,
2.
it's -2 times 1, so -2, so I get a -2. If you remember, when we first started doing, we started writing in like row 1, column 1, row 1, column 2. This one here is row 2 times column 1, row 2, column 2. So for this one here, I take row 2, -2, 5 times column 1, 1, 0. So -2 times 1 is -2, plus 5 times 0 is 0, and I get, that's just equal 7. Hang on. Let's do -7. I don't think it really matters, but. So I get -7 times. So then for the last one, I do row 2 times column 2, so -7 times 0 is 0, plus move over and down, 5 times 1 is 5. And we do notice that we get the exact same answer, 4, -2, -7, 5. However, we know that, you used this term earlier, Cordell, commutative, right?
Yeah.
What does commutative mean? Yes.
Switch around the two things and it's going to be the same.
Sure, 2 times 3 is the same as 3 times 2, right? Our matrix multiplication, is it commutative?
No.
It is not. We proved that in the previous lesson, or the earlier lesson. where if you take A times B, it's not necessarily the same thing as B times A. Is it true with identity? Can I take the identity 2 times A and still get the exact same thing? Well, let's try it. 1, 0, 0, 1 times 4, negative 2, negative 7, 5. Is it commutative with the identity?
4, -2, -7, 5. No.
Well, the first one's going to be 1 times 4 is 4, plus 0. The second one's going to be negative 2 plus 0. The next one's going to be 0, negative 7. Next one's going to be 0, 5.
The exact same, is that?
Proves to be the exact same thing. It doesn't matter which place you multiply the identity by. So we just learned a very important thing about matrices. We learned, you might make a note on this one. This might be is a great test question, non-computation test question. A times the identity of 2 is going to be equal to the identity of 2 times A, which is simply going to be equal to A. It doesn't matter which order you multiply it. So while it's typically not commutative, it is with the identity element. Okay? Damien, you got it? Piece of cake, right? So if I ask you a question, if I say, well, no, we're going to use the identity in a second to begin with, so hold on. Okay. We good? Jade, you good?
What? Yeah.
Okay. Are we on Roman numeral 2?
Yes.
Yes.
Okay. We just did the identity. We're going to use that now to help us with the inverse. Inverse property. Okay, let's review the inverse property. So let's go back to addition. 4 plus what number is going to give me, and what was the identity of addition? What was the identity element for addition? 0. 0. So 4 plus what number is going to give me the identity?
-4.
Negative 4. So the inverse of positive is a negative, okay? What about 4 times what number? What's the identity for multiplication?
Division.
No, identity.
1/4.
No. What's the identity element of multiplication?
Oh,
Zero.
it'll be 1.
1. Identity element of multiplication is 1. So, now you can say your answer, Cameron. 4 times what number equals 1?
1/4.
1/4. So it's the reciprocal. Okay? So what about inverses of matrices? What, I'm going to take A, B, C, or D. Okay? No, we're just stuck in D. Then we're going to multiply it by some matrix. And what do I want the answer to be? If they're inverses, what will the answer be?
-A, -B.
1, 0, 0, 1.
Exactly.
If I take a matrix C times its inverse, it's going to equal the identity. Just like over here, 4 plus its inverse equals the identity.
Yeah.
4 times its inverse is going to equal its identity. Okay, now here's how we're going to notate it. This is kind of a new part. It's going to be A, B, C, D. But to notate the inverse, we do a little -1. So if I take A, B, C, D, that matrix times the inverse of A, B, C, D, I'm going to equal its identity. Okay? I'm sorry?
Who is the lines?
Not
cheating
Detroit.
on us?
No, this is the team my son played for.
High school?
Yeah.
You cheating on us then.
No, I did not cheat. But my son never played against Central. So, and when they came to play against us this past year, I cheered for us.
Oh, okay.
I didn't wear this, I wore this.
Period.
That's good to hear.
I just like this one. Okay, so one type of question, test question I'm going to give you is to say, are the following two matrices inverses? Are the following two inverses? Okay. Well, to show this, to answer A times B, because the two matrices will be called A and B, okay? A times B must be equal to B times A, which must be equal to what?
A,
No,
B, A,
no,
0,
no,
1.
no.
1 0 1 0.
Yeah, I did.
Oh, negative.
1 0 0 1. If it's a 2 by 2, 1 0 0 1. Say it.
Yeah.
In fact, let's don't put the 2 because this is going to be true whether it's a 2 by 2 or 3 by 3 or whatever size it is. Okay? So I will give you an example, something like A is going to be equal to, let's go with negative 1 3 2 negative 5. Negative 1 3 negative 2 5. And B equal to 5 3 2 1. 5 3 2 1. And we're going to say, are these inverses? Yes or no? Okay. So the first thing you're going to have to do is you're going to have to do A times B. So A times B, negative 1 3 times negative 2 5 times 5 3 2 1. Are they inverses?
No.
Let's multiply. Let's see, we know we have a 2 by 2, right?
Yes.
So negative 5 plus 6. Now you understand what I'm doing right here?
Yeah.
Negative 1 times 5 is negative 5, 3 times 2 is 6. So negative 5 plus 6 is
1.
1. Alright, so we have negative 1 times 3 and 3 times 1. So what's negative 1 times 3?
0.
Negative 3.
Plus 3 is,
0.
looks good so far. Okay? What about negative 2 times 5?
Negative 10.
Plus 5 times 2?
30. There's negative 3.
What's 5 times 2?
Negative 10.
5 times 2.
5 times 2 is,
2.
negative 2 times 5 is,
0. 0.
so 0.
My fault.
Negative 10 plus 10. Alright, negative 2 times 3
Negative
plus 5?
6. 0.
Oh,
Let's go with that.
negative 2 times 3 is,
Negative 3.
plus 5 is,
1.
negative 1, thank you. Negative 2 times 3 is negative 6.
Oh, yeah.
Negative 1.
Yeah, we're not the smartest.
Are these
guys.
inverses?
No.
No.
Oh, great.
The answer is no.
Oh! Level up.
Okay. Alright. So you can stop right there. So if it were to be 1 0 0 1, we would have to check the other way around. And you'd have to check B times A.
Right.
But since it's not, you know it's not going to be inverses. Once you get one error, we're done. Okay?
Okay.
You good with that?
Yeah.
Now, type 2, that was test question number 1. Test question number 2 is going to say find the inverse. Find the inverse. Okay, so let's do it. Involve a little bit of math. Let's give A equals, we should actually do this one. Don't we just have, is it 2153? No, a little different. Let's use 2153. And then we want to find A to the negative first. Well, let's do a little bit of math here.
Oh boy.
Oh, you ready?
Yep.
We know that A times the inverse of A is going to be equal to I, correct?
Yep.
So then we know that 2, 1, 5, 3, which is matrix A, times, we don't know the inverse, right?
Mm.
So I think I used A, B, C. Let's just put in letters for these. Let's just put in A, B, C, and D. And what is it going to be equal to?
I.
Which is what?
1 0 0 1.
1, 0, 0, 1. Now we know that to be true. We know that A times its inverse is going to be equal to this identity, right? So let's see what happens here. Let's take the left-hand side and let's actually multiply it. Okay? So what do I have? I have 2 times A, which is
2 A.
2A, plus
1 C.
1C. So that's going to be the first one in my, I have a 2 by 2, so that's going to be my first one. Okay. So what's the number here going to be? 2 times B
2
plus
1 B.
just like regular multiplication, right? Pretty simple. All right. Then when we do row 2, column 2, I get 5A plus, move over, move down, 3C. And then I have 5B plus, move over, move down, 3B. Now I know that that's going to be equal to 1, 0, 0, 1. You with me so far?
Yes.
Damon, you good? Jade, you good?
Yeah.
Ellie, you with us? Just say yes.
Yeah.
That's all I care about. All right.
Where's
Now,
my-
does anyone see something I can do here?
I don't.
Well, go back to our matrix equations. What does 2A plus 1C have to be equal to for these to be equal? 2A plus 1C has to be equal to what? Here's my 2 by 2 matrix. Here's my 2 by 2 matrix. It says they're equal.
1.
So 2A plus 1C has to be equal to 1. And 5A plus 3C
0.
has to be equal to what?
0.
0. And now I have a system of equations that I can solve. What does 2B plus D have to be equal to? And what does 5B plus 3D?
0.
Okay. How do you want to solve those?
Or actually, it's
Oh, 5B plus 3D is 1. Yep. How do you want to solve these equations? We have lots of methods to do it. We could use Did I have it backwards this time?
yeah.
Okay.
I say it backwards.
Alright, so we have lots of ways to solve this one. Do you want to use reduced row echelon form? Do you want to use Kramer's rule? Do you want to use
Let's use like Kramer's.
Kramer's
No,
rule?
no, no, no,
Bro,
no.
that's fast, bro.
No.
Can we just do both?
I thought the other one was.
We'll do one of these.
No, bro. The Kramer's is fast.
Okay, so Kramer's reduced, what'd you say?
I am.
What'd you say? Okay, you lose. You lose. Alright, so let's use Kramer's rule. Alright, so we have 2A, oops, 2A plus 1C equal 1, 5A plus 3C equals 0. So what is D going to be equal to? What numbers do I put in for D?
2 1 5 3.
Alright, and someone tell me, what is that determinant?
How do we find it?
That's where you do
Wait,
Oh,
did
yeah,
we
you
say
multiply.
subtract or
Okay,
add?
yeah.
subtract. You do
So you
multiply
want-
minus, what's that?
So we want.
Sure, it would be 2 times 3 is 6, minus 5 times 1 is 5, and equals 1. Okay? What is D sub x? How do I change D to make D sub x?
I remember.
You do, which one?
The left side.
It tells you what you put it in for.
X.
It put it in for the X. So take out the 2 and 5, put in your answer 1, 0, and 1, 3 stays the same. So what is the determinant of 1, 1, 0, 3?
Will be 3.
3 minus 0 equals 3. Alright, what is d sub y?
Wait, wouldn't it be the other way around?
1 times 3 is 3.
No, I thought we went the other way.
You always start in the
Start
top
with
left one.
okay.
Always start there. Yep. Alright, so what is dy now?
5.
-5.
Okay, so we keep the 2 and the 5 the same, right? And we replace the 1 and 3 with 1, 0. And we get what?
-5.
Yep. 2 times 0 is 0. 5 times 1 is 5. And I get -5. So that means x is going to be d sub x over d, which is going to be 3 over 1, which is 3. And y is going to be equal to, which is going to be -5. Now, I actually used x and y, and I shouldn't have done that, because there's no x and y in this problem. What letters are they actually? No, look again. A and C. So A is 3, C is -5. I'm so used to using x and y. So back to my original problem, A and C, we have that. So the inverse of A, let's see, what did we say A was going to be? 3 and -5? Okay. So do the same thing to find B and D. 2B plus 1B equals 0. And 5B plus 3B equals 1. I really screwed that. Okay. Will someone tell me what D is? What D sub B is? And D sub B. It is, because the coefficients are exactly the same. 2, 1, 5, 3, 2, 1, 5, 3. So it's going to be 1 again.
So for the B, well, so I'll plug in 1, 0 instead of 2 and 5,
Yes, so you plug in 0, 1,
or 0, 1.
and then 1, 3.
Okay.
Uh-huh. Exactly. What'd you get for DB?
I got 2.
You got 2.
Yeah.
0 times 3.
8.
You sure you didn't do DD there?
I mean, DD is 2.
Yeah. Therefore, D is going to equal 2 over 1.
And then B is negative.
Negative. 0 times 2 is 0 minus 1. So there's our inverse.
We're not done though.
Does that process make sense?
Yes.
You good with the process?
Yeah.
Damon, you good with the process? You good with the process? Okay, you ready for a shortcut?
Yeah, please.
I don't like this shortcut because it only works for 2x2s. There's no shortcut for 3x3s. Okay? So, you ready for the shortcut? Let's do the exact same one. We know the answer, right?
Yeah.
So we know A equals, what was A again? 2, 5, 1, 3, right? -513. And I say find the inverse. Okay, so you have to memorize a little formula. Okay, I know, that's why I don't like shortcuts. So let's say A is equal to, let's go back to our generic terms, A, B, C, and D. Okay? A inverse is going to be equal to, are you ready? So first thing is 1 divided by the determinant. So that's gonna be A, D minus B, C. So 1 over the determinant. Which means then, if the determinant is 0, I'd run into a problem here, right? So if my determinant is 0, I don't have an inverse. Okay. Alright, then we have to take our A, B, C, D, and we gotta mix it up a little bit. Okay? So what we would do is, you see the A and the D? Switch places. DA. The C and the B, keep them in the same place, but make them change their signs. So negative C, negative B. And there's your inverse. So let's try it with this particular one, okay? 1 over, what is the determinant of 2153, or in our place? What's the determinant of 2153?
It was 1.
1. Okay. Times, take your A and your D and switch places. So 3, 2. Take your 1 and your 5, keep them in the same spot, but change their signs. So then if you multiply 1 by all of it, you get 3, negative 1, negative 5, 2, which should be 3, negative 5, negative 1, 2, what I got here.
Wait, so that works, bro. So that works every time,
Yes. Or 2 by 2s.
but that's not gonna be on the
What do you,
set. Is that gonna be on the set?
yes, 100%.
Oh,
Find the inverse.
well,
Okay.
that's it.
So which one do you like? The system of equations, all of this, or the shortcut?
The shortcut, get straight to it.
Shortcut gets straight to it?
Yeah.
Let's actually try one then. What if I give you A? Let's do something different. Let's do B.
Wait, and that, when you, so that's the inverse?
This is the inverse, yep.
So we're doing all
Which,
this.
what does that mean if it's the inverse? What does that mean? If I take 2, 1, 5, 3 times 3, negative 1, negative 5, 2, what's that gonna be equal to?
I give you
1, 0, 0, 1. 100%. And if I switch them, it will also be equal to 1, 0, 0, 1. I doubt we're gonna get to it today, but there is a reason why we have the inverse, because then that allows me to solve matrix equations. I'm gonna do that eventually. So you try what you wanna do. Do you have this formula written down?
I don't need anything.
You don't need to write that down?
Yeah, no.
You sure?
Yeah.
Okay. Here's B, matrix B, which we're gonna get to you as, negative 1, 2, 3, 4. Negative 1,
It's a completely different
negative
problem.
1, negative 2. Oops. Negative 1, negative 2, 3, 4. And I want you to find the inverse. Find the inverse for me. Have a good one.
So it's just 4, 2, negative 3, negative 1. Or, yeah.
I do. You should have a fraction in there.
Do I still apply it?
So, remember the formula,
Yeah.
1 divided by the determinant. So what's the determinant?
Oh, right.
What's the determinant?
Negative 4 minus negative 6, 5, 2.
So it's gonna be 1 over 2 times, and now you gotta mess with your 4, right? So what do I do?
So the 4 will be at the top, and then negative 1 will be switched.
Switch the 4 to the negative 1.
5
Negative 3 positive 2. And how do I multiply the scalar? Just multiply the 1/2 to all of them, right? Okay. So what is 1/2 times 4? 1/2 times 2. Negative 3/2 times 1/2. Yeah, negative 1/5. Negative 1/2 times negative 1. 1/2 times negative 1. Negative 1/2.
Okay.
Then
Okay. So we find a determinant the normal way before we flip it, and then we flip it.
1 divided by the determinant, and then you do your little scramble. And that's your.
Oh.
Say what?
This is so easy.
That's easy.
Very
Yeah.
easy.
Did you get that one on your own? No problems? No questions? You good?
Yeah.
You good?
Yeah.
You good? Okay. So, say again? Sure. But don't do it out loud, do it quietly so everyone can do it. Let's go with 3, 5,